Hello, my name is Emily Winkler. I'm in the summer 25 4-week class. This is my submission for the final project for elementary statistics. So we started out this class by taking a survey. The survey had 20 questions total, and there ended up being 37 respondents. After the survey was answered by all of the students, we were asked to choose at least 5 questions out of the 20 to retrieve data from. This would be to later on make graphs, get statistics, and to put this final project together. The 5 questions I chose were pick a random number between 1 and 4, how many hours per day do you typically spend on your phone, which is better, given the choice burritos or tacos, your preferred music app, and then should college in the US be free? Given the choice, yes or no. So we were recommended that we should choose 2 quantitative and 2 qualitative, and then a binary question. So binary is going to be yes or no, quantitative is going to be a word answer, or is going to be a number answer, and then qualitative will be your word answer. So I met those requirements by choosing these. This would end up helping us in the long run with adding different graphs to show a spread of different answers or data. So a big part of this project was cleaning the chosen data. It may not seem very large, but at the beginning it's very important because it will heavily affect your results later on. So when the steps I took when cleaning the data, I tried to understand what each column means. So for example, qualitative or quantitative. And then we also had to check for inaccurate data. So missing data, fix mixed spellings, fixing any errors, and then checking that everything is consistently formatted. So for example, one of the questions was your preferred music app. Some of the examples that people wrote down were Spotify, Apple Music, Musi. Some people would write Spotify with a capital S. Some people would capitalize the A in Apple Music and not the M. Some people would capitalize both. This caused the same word to have different sections because there was different spellings of the word. This created a large issue and skewed the data heavily. So we had to go in and fix those misspellings, make sure that everything had the same capitalization and was spelled correctly. The goal of cleaning the data is to remove any errors, like I said, which in turn produces a more accurate result. We just need to make the necessary modifications without changing the overall meaning of the data. So this is just basically an example of what you want, what you don't want. You can see the left side, all of the words are the same. We have those 3 different categories that all looks correct. And on the right side, we have many different categories because there was different capitalization and different spelling, wrong spelling used. It caused a heavy skew. So for the graphs and stats, these were just some of the heavy ones that we had learned about and focused on early on. So for example, the histogram, box plot, frequency table, pie chart, and scatter plot. These all helped give us a visual of the data to help us understand what it was that we were getting from these different graphs and stats. So for just a couple examples, the histogram showed the frequency of how many times each number was picked in the data set within a certain range. So for example, choose a number 1 through 4, you're going to get the range of 1 through 4. The histogram will show what numbers were picked the most out of the 4 options. The box plot, it'll bring together a set of data using quartiles and highlights the outliers. Here it tells us the median phone usage, where the middle 50% of people fall Q1 to Q3 if they're unusually high or low values, outliers, and how symmetric or skewed the data is. Like I said, that's very visually shown. The frequency table tells us out of values or subjects what was more popular. It also makes it a lot easier to compare data values numerically. The pie chart will show us different sections and gives us percentages of how much an answer was chosen. And then the scatter plot will show any correlation or patterns between 2 numeric values. So, for the first one, the first question I chose was pick a random number 1 through 4. So like I said prior, the histogram will show the different answers from 1 to 4. It gives us a visual representation of how unevenly the numbers were chosen. So we can see how high that bar is for 3, and then how 1 and 4 are kind of similar on the low sides. So that would be our maximum, and it looks like 1 would be our minimum. That we can just get from visually viewing the data. The box plot shows the spread and overall summary of data. This will give the median, the Q1, 25th percentile, Q3, 75th percentile, and then the minimum and maximum through the lines. So you could see the top of the box, the bottom of the box, and then we could see the longer lines that are extended showing us. So the summary stats shows the mean, median, range, standard deviation, and a couple other things like variance. That was just computed through StatCrunch. And then data hours a day spent on phone. I use a scatter plot to represent this. We can see that it's affected by an outlier, 24. We can see that in the QQ plot and also the scatter plot with that dot that is a lot higher than the rest of them. The graph shows a spread of phone use across the graph, but there isn't a clear trend, so that shows that they don't relate. So random number picked 1 through 4, and then hours a day on phone. Clearly those will not correlate. They have no effect on each other. The scattered point, it shows low correlation. Scattered points. The QQ plot is somewhat linear, showing it may be close to normally distributed. Many points will fall below the line, but this does show some skew, and we have that line of dots following one another right in the middle. And then the summary stats again shows the mean, median, range, standard deviation. So for data for the burritos or tacos, here I chose to represent it with a pie chart because it very clearly shows the difference that tacos were heavily chosen over burritos. It gives us that percentage, tacos being 70% and burritos being about 30%. It confirms the numerical data that tacos were chosen over burritos. And then I also chose to show this with a hypothesis test, the z-statistic. This again is all computed through StatCrunch. It's how far your sample result is from the expected 50% under the null hypothesis. And then p-value, the probability of getting your result, 70% tacos, if the true preference is only 50%. The p-value shows there is a significant evidence that more than 50% of people prefer tacos over burritos, and this is also proved through the pie chart because it shows tacos is at 70%. Data preferred music app. The bar graph visually compares how many people prefer each music app, so we can see how tall the bar is for Apple Music and how tall it is for Spotify, showing that those two are going to be the most popular. Other apps like Music and SoundCloud, YouTube, and an entry label 234 are much less common, showing how low the bars are. The frequency table also tells us, or it gives you the exact count and relative frequency percentage of total for each music chosen, and then it seemed that I had thought that 2, 3, 4 may have been a wrong answer, that it may have just been someone putting in random numbers. So I was almost going to delete it, but then I did some research and I found out that 2, 3, 4 is actually a music app that is not used as much as per se Apple Music or Spotify, maybe something more like Musi. So we kept that data in there, even though it did kind of at first seem to be wrong or out of the ordinary. Similar thing here for data should college in the US be free. I chose the pie chart and then the bar graph, same thing. So we have those percentages. No said no was for 30% about, and then yes was similarly 70%. And then the bar graph shows how much higher the yeses are compared to the nos. So for the confidence interval, it's a range of values that is used to estimate an unknown population parameter, like a mean or proportion, based on sample data. A confidence interval gives you an idea of how certain you are about your estimate. It also gives a margin of error by doing the upper limit minus lower limit divided by 2. The confidence interval also helps you understand how accurate results are, avoid overconfidence in a single number, and then make better decisions based off of that data. So for the confidence intervals, I use hours a day on phone question for the confidence interval at 90% confidence and 95% confidence, plus to show the p-value. So the upper one, as you can see, is 95%, lower is 90. This for the 95%, it shows we were 95% confident. The portion of people that spend hours a day on their phone is between 4.4, which is the L limit, and then 7.4, which would be the upper limit. And then we also get our p-value from this. And then the margin of error for that would be 1.316. And then for 90% confidence, that proportion of people that spend hours a day on their phone is between 4.7, and then it looks like there's a typo, that should be 6.8. And then the margin of error for this one was 1.0952. For the hypothesis testing can be done to two different types of data based on proportion and data based on mean, which I'll show examples in the next slides. Just some helpful points that I wanted to put in here because they're important. The null hypothesis. This is the default or no effect assumption. And then the alternative hypothesis. This is what you'd want to prove. So the test statistic, a number calculated from your sample that tells you how far your data is from what you would expect under the null hypothesis. The smaller p-value shows strong evidence against the null hypothesis, and then large p-value would show it's not enough evidence to reject the null hypothesis. Hypothesis testing for proportion question. So the original question was, should college be free? I changed it to, do more than 50% of people think college in the US should be free to fit this. So for this, it showed the proportion of 50% or less, meaning 50% or fewer support free college. And then the proportion is greater than 50%, meaning more than half support free college. The sample proportion I had gotten from StatCrunch was 0.7027. The z-statistic was 2.4659, and the p-value was 0.0137. My conclusion from this was that since the p-value is 0.0137, which is less than 0.05, I would reject the null hypothesis. This means that there is statistically significant evidence that more than half of people support the idea of free college in the US. The sample suggests that support is fairly strong. Based on a graph earlier, the yes bar was a lot higher than the no bar, so this does check out. For hypothesis testing for mean, the question being tested was, do people spend more than 6 hours per day on their phones? The type of data, as I said, was mean. Hypothesis, average phone usage is 6 hours or less, and then average phone usage is more than 6 hours. The sample mean I got from StatCrunch was 5.85 hours. T-statistic would be negative 0.3054. And the p-value I'd gotten was 0.5874. So the conclusion I got from this data was that since the p-value is 0.5874, which is greater than 0.05, I would fail to reject the null hypothesis. This means that there's not enough evidence to say that people spend more than 6 hours a day on their phone. The average could be around 6 or even less based on the previous data. So for regression and correlation, how strong the relationship is shown on the graph can be found by using regression and correlation. Regression specifically shows the relationship, and then the correlation shows the strength of the linear relationship given. The R value 0.15891581. It's closer to 0 than 1, so that shows that there's a weak positive linear relationship between the random numbers 1 through 4 question data and hours someone spends a day on their phone. And we can see this here. It doesn't. If I try to put in a linear line, or not a linear line, but I did try to put in a line, and it wasn't found. Based on the data, the line would have been at an odd point because the data is very different, just kind of going vertically rather than diagonally. So it shows that the pattern is weak and likely up to chance. This makes sense because a random number chosen and hours a day spent on the phone, they don't have any correlation. They are two very separate things. They don't influence each other at all. So there was also an outlier at 24 hours. Someone had written in that they were on their phone 24 hours a day, which didn't exactly make sense. So it just shows that we do have outliers. And it could have also affected or influenced the correlation numbers that we had gotten. and then just that shows over here in the corner from StatCrunch. So my final thoughts from this course and from what everything was learned is that I will probably be using statistics in the future. I'll definitely be using graphs. I'm wanting to get a biology degree, so this is something that I'm sure at some point I'll be using, especially if I go into any lab-related field. I feel that the videos heavily helped in explaining the differences between different graphs. The visual portion of the graphs definitely helped me to understand what different data meant. So I'll go back and just show, for example, the pie chart, the bar chart, basically showing the same thing, just in different forms. It made everything very straightforward. I didn't totally understand outliers until I saw the box plot. I could see that it shows here that there were no outliers, but let's say that there were. These lines up the top would be higher, this one down here might be lower. It made outliers more clear. Something else that really made outliers clear was the scatter plot and Q plot, just showing the point that is so far out from the rest of the data. It really made it easy to visualize. And then I never really realized how much went into cleaning the data. So being able to clean it, go through the pie charts, it really made me understand how much it does go into it and how much every answer, or let's say Spotify and a lowercase s for Spotify, aren't very different, but it can make the biggest difference in your data. I would say that is the end of my presentation. Thank you for listening, and it's been a joy to learn through this statistics course.